Let's use trig ratios to solve for the side lengths of a triangle. So if I'm looking at this triangle, I have this reference angle here, and there's my right angle, so that makes this the hypotenuse. And this is right next to my right angle, which makes this my adjacent side. So I need to figure out which trig ratio to use. I'm going to use the mnemonic device. So, okay, so sine requires opposite and hypotenuse. I have the hypotenuse, but I don't know anything about the opposite side, so now I'm going to deal with that. Cosine uses adjacent and hypotenuse. Hey, that is what I have. So I know that the cosine of 30 degrees is equal to adjacent over hypotenuse. In this case, adjacent is x, and hypotenuse is 32. So if I want to solve for x that is being divided by 32, all I'm going to have to do is multiply by 32 on each side. And that's going to give me an x value, which I'm going to have to plug into my calculator. Now, as you're plugging things into your calculator, one thing to be very careful of is what mode you're in. Your calculator will probably automatically start in radian mode. And if I try and plug this problem into my calculator in radian mode, I'll plug in 32 times the cosine of 30, and it's going to give me some number which actually isn't correct, which also doesn't make sense. We have a side that's less than 5 on this triangle when one of the other sides is 32. That's a very small side. Here, let's investigate what happens when we switch to degree mode, because this is giving us our angle measures in degrees. If I enter the exact same thing, now I'm getting a number much larger, and this is actually the correct answer. This 27.712, and what do we want to round this to? It says round your answer to the nearest tenth. So if I'm looking at that, the 1 will make the 7 stay the same, and my answer will be 27.7. Let's do another example. Okay, now we have this reference angle. Now, that 8 is across from the reference angle, so that must be my opposite side. And across from my right angle, I still have my hypotenuse. So if I use my mnemonic device, which of these requires the opposite and the hypotenuse? Oh, that's sine. Nice. So the sine of 62 degrees is equal to opposite, which is 8, over hypotenuse, which is x. Okay, now with this one, we have to take an extra step because we notice that our variable is in the denominator. So let's go ahead and divide sine by 1. Now, when we divide by 1, we don't change its value, but now we have two fractions and we can cross multiply. 8 times 1 gives me 8. X times the sine of 62 gives me x times the sine of 62. So all we're going to do is divide by the sine of 62, just because that is some number. I don't know what the number is, but it's some number. And once we divide by it, x will be all by itself. This gives me an x value, which I'm going to compute in my calculator. So alpha y equals enter gives me a fraction, 8 divided by the sine of 62, not the sine of 6, sine of 62. And again, I want to round to the nearest tenth, so that 6 will make the 0 round up, so it'll be 9.1. Let's look at this example. This is our reference angle. Now, this is right next to our reference angle, so that's my adjacent side. This is opposite my reference angle, so that is my opposite side. So if I look at need opposite and adjacent. This has my opposite, but it also asks for the hypotenuse, so I know it's not sine. This has adjacent, also asking for the hypotenuse, so I know it's not cosine. Opposite and adjacent is tangent. So tangent of 34 is going to be equal to opposite, which is 12, over adjacent, which is x. Again, this is like the scenario we had on the last problem where we're going to divide by 1 so we can have two fractions equal to each other and cross multiply. 1 times 12 gives me 12. Tangent to 34 times x gives me the tangent to 34 times x. We're going to go ahead and solve for x by dividing by the tangent of 34. Cancel over there so that we have just an x value. Again, I'm going to have to compute that on my calculator and then round to the nearest tenth. So I will have alpha y equals enter 12 over the tangent of 34. And over here, we're going to see that that 9 will make the 7 round up, so we'll have 17.8. Final answer. That's how you solve for side lengths using trig functions.